Okay, so good morning, everybody. Thanks very much for coming along to the session. My name's Adam Jollans, and I work for IBM as the Linux and Open Virtualization Strategy Manager. Okay, and what I'm going to be talking about today is really the intersection between KVM as a virtualization technology and OpenStack as a massively scalable infrastructure as a service cloud software suite. To put this in context, KVM is a virtualization technology, and it's supported by a industry alliance called the Open Virtualization Alliance, which is a collaborative project of the Linux Foundation, which I'm sure you all are familiar with. Okay. And obviously OpenStack has its own sort of parallel foundation in that space. What I'm going to be talking about this morning is I want to start off really with a brief history of virtualization. How did we get to where we are today? What are the considerations? What are the factors? What are the options going forward on this? Then have a look at the KVM architecture, how that works, how that builds on Linux. Look at the OpenStack architecture, and then look at how they fit together. And this is especially relevant because the vast majority of OpenStack deployments actually use KVM as the underlying hypervisor, and I'll show you the most recent stats on that. Then want to just dig into some case studies, some examples of people using OpenStack in conjunction with KVM and why they're doing it, what the benefits they're seeing from that is. So let's start at the beginning and take you through a brief history really of virtualization and how we got to where we are today. And everything started with virtualization, intriguingly, on a public bus in the downtown Cambridge, Massachusetts, where an IBM researcher in the 1960s, obviously they got stuck in traffic or something like that, and he had time to think, and he was thinking about how do you get best use out of the big new computer that they were working on at the Cambridge Scientific Centre. And the trend in terms of virtualization really seems to be happening when there are sort of three things come into play. The first is that the computer is big enough to make it worth virtualizing. Okay, so when you've got smaller computers or initial systems, then those are typically one user or one application. As they get bigger, which are obviously happening more and more and happening to all classes of computing, then people start saying, how do we share this better? How do we share the resources? And virtualization becomes an option. Second key factor in there is obviously the virtualization software, the hypervisor that enables that sharing to happen. And the third thing that is present in a number of these cases, but not all, is hardware support to make doing the virtualization easier. Now, there are and have been ways of doing virtualization without any hardware support. Those are especially either challenging or brilliant, depending on which way you look at it, but there's a lot more work you have to do if you don't have the hardware virtualization in place. So a lot of these things happen where you get those three things happening together. Anyway, going back to virtualization on the initial IBM mainframes, this happens in the 60s with a product called ZVM now, and that enables the computer to be split up into lots of computers like the original computer. Next stage on this happened in the 1980s when the Unix systems got to be sufficiently big that people thought, let's actually split these up and share the resources between them. So the Unix systems then had a number of different virtualization options. Now, x86 systems were also getting bigger and bigger as we went on through this, but there was more of a challenge in terms of how do you virtualize them. Okay? Because there wasn't the hardware support in the x86 processor, and so as you started to do virtualization, you got into doing instructions that would just trap the machine or override what somebody else was doing, and so on. And VMware came up with a brilliant idea in terms of how to do that virtualization, and they said, well, if we look ahead in the code that's running to the next few instructions, we can work out if an instruction is going to be bad for what we want to do, and then we can trap that, and we can then sort of handle that instruction in a different way. And that was the origin of the first serious hypervisor for the x86 with VMware. Obviously, there are a lot of technical challenges to be overcome, but they had a successful hypervisor there. It did have a Some challenges in terms of performance, just because of the fact you're doing all this work in terms of looking ahead and translating automatically and so on. But that was the first hypervisor that emerged for x86 systems in the sort of late 1990s, early 2000s. The next stage that happened was the Zen project. So this was from Cambridge University in England, and they were actually looking at how do you build a cloud and do it with distributed servers called Xeno servers. But in order to do that, they realized they needed to have a hypervisor on each of those servers, and that's where the Zen hypervisor then came from. And they had a different approach. Okay, they said, if we actually change the operating system to avoid it trying to do any of these illegal instructions, then we can run it safely in software on the system. So Zen had this approach, which is called para-virtualization. Okay? Obviously, the challenge there is you've got to be able to change the operating system in order to be able to use this way of doing the virtualization. Okay. So this worked especially well for open source operating systems like Linux, for example, because it was possible to actually go in and change the operating system so it was safe and then run it para-virtualized within the hypervisor. This gave increased performance because you'd done the hard work of making the virtualized machine safe one-off rather than doing it dynamically every time. What then happened in the mid-2000s was that Intel and AMD added hardware virtualization support into their processors, and this then enables many more options to sort of be done in terms of how do you virtualize x86. And obviously all the while here, x86 servers were getting more and more and more powerful, and the default which had happened during the 1990s of one application per server, especially on Windows systems, was becoming more and more untenable because these were big systems. You wanted to run lots of things at the same time. So x86 hardware virtualization then enabled a number of different solutions. One of these was the KVM hypervisor, which came out of a company called Cumbernet in Israel, and they had this brilliant idea that you could change Linux into being a hypervisor, and I'll explain a bit more as to how that works. Okay. They depended on hardware virtualization support. So they assumed that the servers going forward would all have hardware virtualization support so you could actually use this. Okay. And obviously 10 years on from then, every x86 server does have hardware virtualization support, so this is a good assumption now. VMware and Zen have gone back and also used hardware virtualization, as has a number of the other people doing that. The final stage, which I'm not going to go into any detail today because it's one of the areas that everyone in the industry is looking at, is you've now got the emergence of containers as ability to virtualize effectively the user space for the application without virtualizing the operating system. There's some potential benefits to using containers as an approach for virtualization, as well as an approach for packaging. You can cram many more of them onto the same machine, is one of the biggest advantages. There's also some challenges, especially in terms of how tight can you make the security between the different containers. And obviously these problems will eventually get solved, but at the moment that might be a reason you go for virtualization rather than containers. So that's an area, obviously with Docker coming out in terms of application packaging, that's going to be very, very big going forward. But I'm not going to talk in detail about that, though if you want to we can have a debate in the Q&A. So that's where we've got to today in terms of virtualization. We've now got to x86 systems being big enough to want to virtualize, having the hypervisor software available, and also having the hardware support in there. And the majority of systems are now virtualized in terms of x86 systems. So as we look at KVM and we look at OpenStack and we look at the management tools, I'm going to use this as a sort of a conceptual framework so we can sort of look at them on both the same basis architecturally. It's very, very simple. Computer systems have computer resources, they have storage resources, they have networking resources. There's a whole set of management tools that manage those. You've got the applications running on top of them, and you've got a user interface. And that'll become clearer as we dig down in terms of each of the architectures. KVM is actually quite limited in terms of what it does. So what KVM does is it's about the virtualization of the compute nodes. Right? That's what it does. It does it well, as I hope we'll show. But in order to then manage it, you then need some other products, and a lot of those are open source, including libvirt, which is a library for managing hypervisors, manages multiple hypervisors, and some higher level tools, which I'll dig into in this space. So let's have a look at the KVM architecture. Let's start to dig down into how KVM works. So KVM is an open source hypervisor that's based on Linux. And the way it works is that there's a kernel module that then plugs into the Linux kernel, and it turns Linux into a hypervisor, from an operating system into a hypervisor. Okay. Now, if you start to think about what a hypervisor needs to do and what an operating system needs to do, there's actually a number of common tasks you need to be able to do. So both of them need to be able to start and stop processes, both of them need to be able to manage memory, both of them need to be able to manage hardware devices, so you need device drivers for that, and so on and so forth. So a lot of the things that are in Linux, in terms of memory management, scheduling, device driver support, can then be used by KVM, and they don't have to be rewritten. So this is avoiding reinventing the wheel, leveraging the capabilities that you've already got in Linux. And as you'll see as we go through and see some of the strengths of KVM, Linux is very, very good at a number of things in terms of managing processes, in terms of security, and so on. And so KVM inherits those capabilities. So first part of KVM is module, kernel module that plugs into Linux, turns it into a hypervisor. This is now merged into the Linux kernel, into the source tree. It's in all the standard distributions, so it's there and people are able to use it. On top of this modified Linux, you then are able to run multiple virtual machines. You can run Linux virtual machines, and you can run virtual machines for other operating systems, because it's a virtual machine, so you can put into the virtual machine anything that you could put onto the original sort of hardware system. It can be the same Linux, it can be a different Linux, okay? And the only thing that's different in this space is it then has a second open source project called QEMU, which provides the power virtualization of the devices, of the peripherals. So that then needs to run within each of those virtual machines. Example of what might be another application there, you might want to run Windows virtual machines alongside Linux virtual machines. I'm not sure why anybody would actually want to do that, but some people do. Okay. Yes. Okay. Which actually increases security in that space. So the ability to run other virtual machines is possible there. You also might want to do it in terms of having a new version of Linux. So you've got your operational system and you add a new version of Linux and you bring that up with in another virtual machine. You can also run Linux applications standard on top of Linux. Okay, so if you take something like Red Hat Enterprise Linux, you're able to run that virtualized and run standard Linux applications as well as Linux applications inside the virtual machines. In addition, because you can configure Linux as much as you want, you can decide, we're not going to do that, we're going to take out that support, we're just going to have this as a cut-down hypervisor that can run lots of virtual machines and run them well. And that, again, is what Red Hat have done with Red Hat Enterprise Virtualization, right, which is just the hypervisor plus some management tools there. So that's the basic architecture. It looks very, very simple in those block diagrams. Obviously, there's a lot of really cool invention gone into it. One of the interesting things that's happened recently in terms of the architecture is following Linux, this has moved from being just x86 to being multi-platform. Okay, so KVM is now available on the Power 8 processors. It's in technology demo mode on IBM Z systems, the mainframes, and it's available on the ARM64 processors. Okay, so this is probably the hypervisor that's available on most different platforms. And obviously then have some commonality in terms of management, in terms of building things on top of that you can move from processor to processor. Now, you can probably work out why the big machines that are too heavy to lift, like the IBM Z systems, you might want to virtualize there. Why would you want to virtualize on an ARM64 machine? Well, one of the reasons is when you look at bring your own devices, people bringing in their own devices to companies and they want to use it for both their personal data and information and the corporate data and information, you can actually use virtualization to have a very clear separation between personal and corporate data on the same machine, on the same smartphone, on the same tablet. So that's the potential use there. So that's the KVM architecture. What's the benefits of KVM, of this new way of doing virtualization? So the first reason that's come out very well is performance. So this is the latest grab I've done of the benchmarks that have been posted on SpecVirt, the new version SpecVirt SC 2013. So these are industry standard virtualization benchmarks. And in terms of the graph here, the green ones are using KVM, the yellow one is one done by HP with VMware, and the blue one is one done by IBM with the IBM Power 8 processors with the sort of the native virtualization technology. Now, a couple of things to sort of see from this. There's not a lot of comparisons we can do because there's actually only one VMware with that one, but if you compare a 16-core VMware with a 16-core KVM, then you'll see that there is an edge in terms of performance for KVM versus VMware. And where we've seen them done on identical machines, there's maybe a 10%, 20% sort of advantage there in terms of that. Now, obviously, asymptotically, you're going to go towards 100% in terms of performance. The goal is 100% of bare metal performance. So there's not a lot you can sort of increase there. Where it's really big in terms of the differences is when the support for multiple cores. So KVM inherits Linux's support for lots of cores, lots of memory, and so this means that you're able to have much bigger benchmark results because KVM is able to manage the massive memory, able to manage the massive cores. The biggest one here, which has just been posted by Lenovo, is with a phenomenal E7 120 core machines, and that is by far the biggest one, but you'll see a whole spread there in terms of strong performance results for KVM. Now, the benefit of being able to support lots and lots of cores is really when you get into cloud computing. And if you think about people providing cloud computing, what you're trying to do with cloud computing is support as many users as possible on the same system, because that's then able to cut your costs, and therefore you can have a reduced cost that you then sell on to your clients. So packing more and more virtual machines onto the same system is of a real benefit for cloud, and it's one of the reasons that OpenStack is using this. So strong performance we're seeing in terms of KVM. Another really strong capability of KVM is in terms of security, and this is another area where KVM is able to inherit the strengths of Linux. So those of you who are familiar with Linux probably know of something called Security Enhanced Linux, or SE Linux, which was some code originally developed by the National Security Agency, who decided they were going to be really nice, and they then contribute that back to open source. So it provides a very high level of security. It's a different type of security. So standard Unix or Linux systems use something called discretionary access control, which means that if you've got a certain role, you're then able to do anything that that role permits you to do, effectively. Discretionary access control says you're only allowed to do the things we have explicitly allowed you to do. Okay? So it takes quite a bit more setup in that space, but it does mean that if you're able to trick yourself into a different role, you don't automatically get access to this phenomenal access all areas path. Okay? Mandatory access control is what's used in the very high security systems. So this is the need-to-know security. And because KVM is built on top of Linux, it's able to then exploit the SE Linux capability inside Linux and the combination is called SVirt, and this then provides the need-to-know security between the virtual machines. Okay? And this is all done, this isn't something that the user has to do, this is all done in terms of the build then of the virtualization. Okay? What's the benefit of doing that, apart from the fact you're sort of nervous as to whether my application might override my application? Well, again, it comes back really to cloud and to multi-tenant clouds, and when you have a cloud system that you're going to have more than one different client using at the same time, this provides a very hard level of security between the different virtual machines, much better than the normal security. So it enables a reassurance in terms of high level of security for multi-tenant clouds. There's also various certifications being done in terms of the formal security certification. So, for example, EAL4+ for KVM in RHEL 6 and SLES 11, okay, on various pieces of hardware. So security is then another really strong part of KVM in terms of it being a hypervisor. So now let's look at the management tools to manage KVM. As I said, KVM is really just about providing a hypervisor. So in order to do anything useful with it, you need to be able to manage it, and there's a whole set of different options here. The first one, which I'm sure a number of you are familiar with, is libvirt. Again, it's another open source project. It's a set of libraries that enable you to manage hypervisors. It works with much more than just KVM, but it does support KVM, and it provides a real command line, so people like real command lines and therefore able to script on that, and it provides remote management, so you can actually manage from a different system. It's also the basis for nearly all of the other management tools, so using that libvirt interface becomes key. The next one is a project called Kimchi. So Kimchi is an open source project that IBM started a couple of years ago, really to tackle the question of how do we do easy management of KVM on a small number of systems, so it's very easy to set a virtual machine, start, stop them, monitor them, assign resources, and so on. Okay. If you're interested, you can see Kimchi in action downstairs on the IBM booth. Right, so you've got it running live there, and you can sort of see what it does. It uses an HTML5 through a web browser, so there's nothing particularly new you need on the client as long as you've got a HTML5 compatible web browser. And it then interfaces through a daemon to libvirt and enables you to manage KVM. It can manage KVM on x86, it can manage KVM on Power 8 systems as well. Okay. It's useful for managing small numbers of servers. So this isn't the sort of thing you're going to manage the CERN cloud with, okay? But if you're starting off and you want to be able to sort of manage that, Kimchi provides a really interesting solution there. The next step up is OVirt. Okay? So OVirt, again, is an open source project. This one was started by Red Hat, okay? And they purchased Cumbernet, and they purchased the engineers back in the sort of 2000s for KVM, and they got some software which they then converted into open source. And this is about managing tens to hundreds of servers of KVM servers. If you saw the OpenStack talk yesterday, you'll have seen the analogy of pets and cattle in terms of what your servers are like. So pets are things we name and we love and we care for and we update. Cattle are servers where if one of them goes wrong, we throw it away and get another one. Okay, this is about managing pets. Okay, this is about managing servers that you're going to be managing individually. You can actually do a lot with this. You can do it remotely. You've got a user interface, a good user interface that you can use to manage it. OVirt is an open source project. It then becomes, Red Hat has taken that and they have this as the Rev management module, which is in Red Hat Enterprise Virtualization. And this at the moment manages KVM on x86. The other one, which we'll talk about in a moment, that you can use to manage KVM is OpenStack, okay? And that's where you get into the thousands and tens of thousands of servers and you're managing cattle. KVM futures. So one of the big trends and one of the key themes that we saw at KVM Forum last October in Düsseldorf was heterogeneous processor support. So we talked a bit about ARM64, Power 8 processors there. Again, you can see, if you want to see KVM running, go and see it down on the IBM stand on the exhibition floor. And also graphical processor units. So KVM virtualization for those is starting to come in and be looked at. Another really key use case we're seeing in terms of KVM is network function virtualization, which is moving away from network functions being provided as appliances, that you have the box and the hardware and the software installed on it, and that's what you get, to having that same routing capability handled on top of commodity x86 hardware. So network function virtualization is a trend that's starting to come through the industry in terms of moving away from specific network devices to networking being done on standard devices. NFV needs a hypervisor to be able to provide that, and quite often that hypervisor is KVM. KVM is also working on further performance improvements, especially needed as you get onto the bigger systems, so minimizing the locks, minimizing the contention between different systems. And then the other interesting thing that's happening on KVM, this is the experimental phase, is nested virtualization. Okay? So this is the ability to run KVM inside KVM. Okay? And again, you may say, why would you do this? And the reason to do it is that you're able to provide a new system on top of an existing system, or you can have a system that's got both the current system and the new system with the new software. So you have a layer of KVM, then KVM with OpenStack, old system, KVM with OpenStack, new system. So nested virtualization is an interesting area. There's research papers that you can browse on this. It's something that's been in place on IBM mainframes for virtualization for 30 or 40 years, so it has quite a few uses in terms of that. Again, there's some technical challenges in terms of getting there and in terms of what you've got as the hardware support. But I think that's going to sort of come through in terms of just the whole manageability of these systems. You could also potentially have a hypervisor in firmware that's KVM, and then you load onto that KVM as a software level. So that's the KVM part. Let's now sort of look at the cloud part, look at OpenStack, and then we'll look at why there's a real sort of a synergy between them. If you're building open clouds, there's some key things that you want to be able to do. Okay. Firstly, the cloud needs to be secure. It's probably the topic I'm hearing most of at the moment around computing is security. Okay? The cloud needs to be secure. You need to be able to be sure when you're sharing users that you're only able to get to the stuff you're allowed to get to. You're not allowed to get to other people's data, and you're not allowed to trample over the operating system. Resilience, again, in terms of cloud becomes very, very important because people start to assume the cloud is going to be there and it'll always be available, and get very disappointed when the cloud isn't there, and at that stage, especially if you've got an open cloud, may decide, well, I'm going to take my open cloud workload and move it to another open cloud workload that will give me the resilience. So the resilience, the availability, reliability is key. Performance, again, is key in terms of people getting the service that they want, and the scalability of open clouds goes into thousands or tens of thousands of nodes. Open clouds can also potentially be heterogeneous, so have different processors within them, and the interoperability to be able to share workloads to cloud bursts from one cloud to another cloud if the load goes up becomes key. So the OpenStack diagram is a bit more complicated than the KVM diagram, but we can sort of map it onto the same framework here. So OpenStack works on the principle that everything is good. Okay? So it's your choice in terms of storage, your choice in terms of hypervisor, your choice in terms of underlying network, and then there's the pluggable modules that then provide that support. And obviously, as you sort of start to build clouds that are going to be these Uber clouds that cover everything, you want to be able to work with the legacy systems as well as the new systems. Within the management tools, there's a whole set of modules The really key ones to pick up on are Nova, which is the module that handles compute. Okay. Swift and Cinder are the modules that handle storage, two different types, and Neutron is the module that manages networking. And then there's a user interface, and the GUI for OpenStack is called Horizon. You can also interact with it via a command line, or you can interact with it via an API, and probably actually the API is the most useful because you're going to be scripting this anyway, because you've got tens of thousands of nodes, so you don't want to have tens of thousands of systems programmers. Other things just to highlight within it is Heat is the orchestration. This is about the automatic management of OpenStack, and again, as you get into thousands and tens of thousands of nodes, it becomes really key. So if we dig down just a bit of this, the design principles of OpenStack are firstly open, which is good. If you've got open in the name, it's especially good for a conference like this. It's an open development module, it's an open design process, it's an open community. It is very democratic. There's no benevolent dictator for life for OpenStack, so it really is committees for each of the modules and then an overall technical committee in terms of making the decisions. OpenStack started when two organizations got together in terms of trying to solve the problem of big clouds, and they were NASA, who contributed the compute and networking capability, and Rackspace, who contributed the storage capability. It's a general purpose cloud, infrastructure as a service cloud. Okay, so it's looking at how do you balance compute, storage, network, how are you able to provide that. Now you can decide, right, I'm going to provide a storage cloud and just focus on Swift or Cinder in that space, but it's been built as a general process, very much with modularity in this space. Principle in terms of things being massively scalable, so being designed for thousands and tens of thousands of nodes going up beyond that. And a principle in terms of it being multi-site and being resilient and recoverable. So, for example, in the storage capability, in the Swift object storage, data is replicated 3 times by default. Okay? And that means that if your backup goes, you've still got 2, so you can reconstruct the one that's gone, and you haven't lost that resilience whilst you're reconstructing the one that's gone. So a principle in terms of very high levels of resilience. So Nova is the software that manages the compute nodes. Now, as we said, it actually then interacts with hypervisors. So Nova doesn't have its own hypervisor. It provides pluggable modules, so you can choose the hypervisor in that space or have a mixture of hypervisors. And it starts and stops virtual machines, it schedules them, decides where it's going to run them, monitors them, moves them around. Okay, and it uses a couple of other components. So Keystone is authentication. So this is really checking out, have you got the permission to do what you're asking to do? Okay. And then Glance is the image service, which provides the virtual machine images that you then run in these nodes. And Glance needs something behind it in terms of actually managing the storage, and it typically uses Swift as object storage. So the central part of OpenStack is Nova. Nearly all clouds have some compute capability. There's a few that will just have storage only, but nearly all of them have some compute capability. Now, this is interesting when we look at then the how much are people using OpenStack, which hypervisors are they doing this with. Every 6 months, around about the OpenStack conference, OpenStack released a user survey where they've surveyed people and said, what are you using with OpenStack? What are you using it for? What modules are you using? What hypervisor? What networking? What operating system? And so on. And this is just the hypervisor snapshot of this. And they've split it down between proof of concept, dev QA, and production. And you can see that KVM is by far the most popular hypervisor being used with OpenStack. And we'll go into why that is. But this is how is it being used in practice. KVM, by far the most popular hypervisor. Now, the eagle-eyed among you have probably been adding up the numbers, okay, and working out, okay, when I add those up, it comes to more than 100%, and it does. because quite often people are having multiple hypervisors that they use in their OpenStack cloud. So that accounts for that. One of the other interesting things is when you look at the comparison between proof of concept, dev QA, and production. And so KVM is about the same, and slightly more people using it in production than have used it for proof of concept. VMware's ESX, you'll see people have started off on doing proof of concepts, and dev QA has dropped, and by the time it gets in production, they've decided actually they're going to go for something else. So some interesting things coming out in terms of the hypervisor usage, but probably the top one out of this is that KVM is the most popular hypervisor used with OpenStack. And I'll give you some examples, some real examples of this in a moment. Some of the other modules that are in OpenStack, Keystone provides authentication, okay? And it provides authentication to everything. So every time you're sort of calling another module, that's doing the double checks in terms of, are you allowed to do what you want to do? And again, that can have multiple backends in terms of using existing authentication. So OpenStack won't invent its own solution if there's already one in place. It'll plug in and use existing solutions. Block storage, so basic storage capability for databases, persistent storage is a service called Cinder. And networking is a service called Neutron. This used to be part of the Nova project, the compute project, and it's been separated out and therefore gives a much neater approach to that. And again, choice of network behind there. Glance is the image service. This is where the virtual machine images are kept, has a catalogue of images, it can register them, fetch and delivery of them, and then those can be stored either in Swift, which is the object storage capability provided by OpenStack, or in a local file system. And the object storage manages unstructured objects, so it's durable, it's got this 3 times replication, okay? And that'll then plug into the back end in terms of whatever underlying disk storage you're using. So provisioning a VM, just an example of how things would work. This is probably the very basic thing in terms of using OpenStack. So the user interface, whether it's Horizon or the API, will do the request in terms of provisioning a VM. It'll go to Keystone in terms of authentication, come back saying, yes, that's okay. Nova will then start communicating, deciding which virtual machine which is going to run it on, provisioning that. It'll then go to Glance in terms of the image service to get the VM image, which will go to Swift in terms of the storage, comes back, puts it in there, set up the storage, set up the networking, and then you've got a virtual machine. So most OpenStack implementations will use the majority of the modules. Okay? But again, it's a much better way in terms of designing and configuring the system to have the multiple modules. OpenStack is continuing to develop at a fast rate. This is one of the biggest, if not the biggest, open source project ever. It's on a par with Linux in terms of the size of this project, and it's only been going for 4 years, right? So this is phenomenal take-up, phenomenal interest in it. Every 6 months, there's a conference that both looks at the design for the next 6 months and also does technical education. The latest release is Juno, so that's the current release of OpenStack. At the Paris Summit back in November, they decided that the next release was going to be called Kilo, in recognition of the kilogram that's actually sitting in the Paris Museum. And some of the things that are coming into Kilo are they're doing a lot of work on updating the user interface to improve that, enabling Glance to store artifacts beyond just images, so other objects there. Bare metal provisioning, so how do you provision OpenStack where you haven't even got a virtual machine there in the first place? Okay, and introducing a message and queuing system. So why is KVM and OpenStack, why are those two fitting together so well? Firstly, if you look at what OpenStack and an open cloud needs in terms of the hypervisor, KVM excels at those criteria. So when you have tens of thousands of nodes and tens of thousands of servers, you want the hypervisor to be low cost because you're having to multiply everything by 10,000 or 20,000. And KVM being open source fits in with that very well. We've looked at the scale and the performance benchmarks in this, and we've looked at the security. And again, those are two things that are key needed there. And interoperability of being able to connect with other systems becomes key. So intrinsically, there's a good reason for running OpenStack on KVM. Secondly, they're both open source projects, so there's a development affinity between KVM and OpenStack. And KVM is the default hypervisor for OpenStack development. That wasn't always the case, but KVM has now become the default hypervisor that the developers are using, and that tends to mean that KVM is the best supported, easiest to deploy, got the most full-featured driver. And we can see that in terms of the usage results on the graph we showed a couple of slides ago. So let's now look at a few examples in terms of OpenStack being used with KVM. And I'm going to talk about 4. We've got slides for 3. One of them I only heard about a couple of days ago, so I'll just talk to that. First one is NTT Com. So NTT is a very big telecommunications company in Japan. Within that, they've got a division called NTT Com, and they provide public clouds. Okay? And they've based one of their public cloud offerings on OpenStack and KVM. NTT are actively involved with the OpenStack development community. They're actively involved with the KVM development community, and they're really pushing this as a sort of really good use case. Why have they gone for OpenStack? Okay? They've gone for it in terms of it being a flexible infrastructure. Okay? They can use it to unify what they're doing, fits in well with software-defined networking that's coming through, okay, and provides a good GUI portal in there. So a big Japanese public cloud using OpenStack and KVM. Second one is Intel IT's internal web. So this is Intel's private cloud. Okay. Again, this has been going on for quite a few years in terms of it being used here, and you can see this by the code names of the OpenStack releases, which are alphabetical. So their initial deployment with 1,000 virtual instances on OpenStack Essex. Now they've moved up to 3,500 instances built on top of Grizzly. What do they see as the benefits of using KVM with OpenStack? Okay. So they did a study, right? They were looking for performance, which OpenStack and KVM provides. They were looking for stability. They were also looking for a tight linkage between OpenStack and the Linux kernel. Okay. What did they learn? Well, they learned that you need to sort of know what you're doing here, because it's still quite complicated. This is still very much the frontier in terms of sort of deploying OpenStack. They found that there was a challenge sometime in terms of Windows guests, okay, in terms of deploying this, and there's obviously an obvious answer to that, okay. And they found that there's that they needed, as they were going to oversubscription, you don't want to oversubscribe too much in terms of vCPUs. The third one is probably my favorite in terms of the examples here. So I'm sure you're all familiar with CERN as a research organization into fundamental particle physics, and they have the fantastically named Large Hadron Collider out in Geneva, which is seeking to find new particles by banging lots of particles together and seeing what happens. Okay? And I don't think there could be a cooler job than that. Okay. Okay. Now, once you've banged all these particles together and seen what's happened, it has moved on from the early days of particle physics where you looked at the tracers in the cloud chambers. Now you need a phenomenal amount of computing resource in order to actually process that and decide whether or not you found the mythical Higgs boson, which they now have actually found. So it needs lots of scalable computing resource. It needs that on demand, right? So it won't need the same level all at the same time, but it'll suddenly need to be able to ramp up massively in terms of providing it. So CERN have built their private cloud on top of OpenStack and KVM, and also a couple of other open source projects of MySQL and RabbitMQ. Currently, right, they've got 3,200 hypervisors and servers with a large number of cores underneath it. They reckon they're going to be over 100,000 cores being supported. Their requirements were SCaLE, for obvious reasons. They wanted to be able to support this technology and developer ecosystem, but also they wanted to be able to integrate with the existing IT services. The last example I just wanted to touch on, okay, is a company called City Networks. They're based in Sweden. Okay, they run a very big public cloud called City Cloud, which has something like 50,000 virtual machines across multiple sites in Europe. So they're one of the biggest cloud providers in Europe. And again, they were looking at how do they get the efficiency, how do they get the performance, how do they get the ability to support multiple sites in terms of providing this with OpenStack and KVM. So they have a production public cloud system with 50,000 VMs running OpenStack and KVM. So I hope I've been able to sort of explain what the potential advantages of KVM are, what the potential advantages of OpenStack are, and especially why the two fit really well together. And as we see OpenStack adoption sort of rise, we think we're also going to see KVM adoption rise in there in terms of being the majority hypervisor. You want to find out more? The Open Virtualization Alliance, with an extremely long URL of openvirtualizationalliance.org, okay, has a set of resources on its website. One of the most interesting is a white paper that was sponsored at the end of last year by IDC, looking at open virtualization for enterprise and OpenStack clouds. And this is free to download off the OVA website, so please go along, download it and have a look at that. And that sort of looks in terms of this congruence between the two. If you really want to get down into the details, Linux Foundation has training courses. It's got one on Linux KVM virtualization, which is a 4 or 5 day course, so it's really serious stuff that goes into it. And obviously, the OpenStack Foundation at openstack.org has a lot of useful information, and it has probably about 100 case studies now up there in terms of people using OpenStack and why they're using OpenStack and what the benefits they're getting are. So that's what I wanted to say. I think at this stage I'd like to open up. Are there any questions? Sure.
How are they, have you heard about in the industry any...
Sorry, so people hear.
Identity services that's going to be coupled into the OpenStack service offerings?
I think it's using LDAP as a back end.
Yeah, like common identity, maybe federated, or would that be part
I'm not sure.
Would that be part of Keystone?
Yeah, it's identity management. I know one of the leads.
Okay.
So it's definitely a project that I know is a lead in production.
Yeah, so it's in Keystone in the authentication.
Okay. One more question is on crypto key management in terms of Barbican. I think is another project that it's kind of at its infancy now.
Yes, yeah, that's just starting there.
Yeah, so not too much traction yet on that one, right?
No, I mean OpenStack, as I say, is a fairly young project. It's 4 years old, but as it starts to get deployed, new things are being sort of added in there, and so yeah, Barbican's starting to bring that in.
Yep. Makes sense.
Okay, thanks.
Thank you.
And please sort of connect to the end. Any other questions?
You mentioned GPU processors as one of the types covered. How is the state of PCI and GPU card pass-through on KVM?
So the PCI stuff is one of the areas we've been looking at in terms of performance on that for KVM. A lot of that's handled by the QEMU component rather than the KVM component. So obviously something they're going to have to solve there. I don't know the details of that. Any other questions?
question about the use case. You mentioned CERN using OpenStack. So it's a massive particle collider. But what the use case of cloud for them? What they use this cloud technology?
So the question's about the CERN use case. So it's about then processing vast amounts of data. So when you've collided it and you've got all the sensors, you've got a massive amount of data, and then you need to analyze it and you need to sort of work out what that means, and that needs massive computing resource, but it's not all the time. They're not doing these collisions sort of continuously, so it's at that stage you suddenly need on-demand massively scalable resources. So the use case is being able to have on-demand massive resources available to you for that massive amount of data that's coming in. Okay. So it's not a use case that everybody is going to have, because not everyone has a particle accelerator in their back garden. But for them and for other sort of research people, it's massive amounts of data suddenly need to process. Okay, well, thanks very much for your attention, and enjoy the rest of the conference. Thank you.